All right, this is the second half to the Chapter 8 review. For the number 8, we see we have x squared plus 2 times e to the x. I don't have a u sub available here. You might be tempted to distribute, but that makes this much more complicated. This is going to be a by parts. All right, and so if I do my u and my dv, the u is going to be the x squared plus 2. The du then would be 2x dx. The dv will be e to the x dx. That makes v equal to just e to the x. Okay. So then the integral of u dv is going to be uv. So it'll be x squared plus 2 times e to the x minus the integral of v du. So 2x e to the x dx. Now, this is better than what we had, but it's still two things that don't quite go together. So we need to do another by parts here. All right, so we got to do another u dv here. And dv is going to be e to the x dx. U is going to be 2x. Du would be 2 dx. V will be e to the x again. Okay, so I'm just going to repeat what we had there. X squared plus 2 times e to the x minus, and then we'll put parentheses down, uv, so 2x e to the x, minus the integral of v du. All right. Now we're almost there. We have what we started with here, x squared plus 2 e to the x minus 2x e to the x minus, so that turns plus 2 e to the x plus c. And that's our answer. Okay. So it takes a little time. You gotta be real careful, especially with that negative, but that's what we get there. All right, number 9. Again, u sub would be tempting to make like that bottom u, but we don't have an x up to help us with the du part. We aren't doing a long divide here. We don't have really anything to divide into it. So I gotta think something else. And what I see is 16x squared is 4x squared, and 25 is 5 squared. So we have a u squared plus a squared. And so this is an arctangent look. All right. And on that arctangent, what we're going to want to do is let the u be the 4x, the a be the 5. And so if you kind of just follow the format, it's the 3 is hanging out front, and then we have a 1 over a to go with it. So it's really going to be 3/5. Again, the 3 is just kind of tagged on, and then we do 1 over a as part of the start of this. Arctangent of u over a plus c. So if we understand the format and kind of how the arctangent works, these are pretty simple, but it just takes a little bit of practice with them. Right? Number 10, I've got x squared plus x minus 12. I've got this x minus 10. I don't have a u sub that if I take the derivative of this, I don't get that right there. So I'm going to think of this as a partial fraction. All right. So I factor this into x plus 4, x minus 3. And I'm going to rewrite this as a over x plus 4 plus b over x minus 3. Okay. So now what I want to do is be smart about it. If I multiply by the common denominator, I get x minus 10 equals a times x minus 3 plus b times x plus 4. Okay. So now I'm going to let x equal, say, 3. All right, and then that gives me negative 7 equals 0, and then 7b, that leads us to b equal negative 1. And then I'm going to go x equal to negative 4. I put that in, I get negative 14 equals negative 7a, and that goes away, so that leads me to a equal to 2. All right, so that integral that I did not know how to do before now turns into a, so 2 over x plus 4 plus negative 1 over x plus minus 3. And when we do the derivative or integral of that, we get 2 natural log of x plus 4 minus natural log of x minus 3 plus c. And that's totally fine, or if you want, you can bring that up and then divide by this, and you end up with the natural log of the absolute value of x plus 4 squared over x minus 3 plus c. So that would be combining it all using log rules. They probably would leave it here, I would guess, but you never know. Now we get to 11. You see the top degree is bigger than the bottom, and so this is a long division idea. Right, so off to the side. We don't know how to integrate this, so let's change it. Let's take 6x squared plus 11x minus 5. Let's divide that by x plus 4. So what do I have to do to x to get it 6x squared? I have to multiply by 6x. You do that to both of them. We subtract. 6x squared cancel. 11 minus 24 is a negative 13. Bring the negative 5 down. To get x into this, I have to multiply by negative 13. It's going to give me negative 13x and a negative 52. Subtract, and we get a positive 47. Now that comes up and gets written as 47 over x plus 4. So this integral, or this fraction, which I didn't know how to work with, I'm going to change into 6x minus 13 plus 47 over x plus 4. That is exactly the same as this. And this I know how to integrate. That goes to 6x squared over 2, or 3x squared, minus 13x plus 47 times the natural log of the absolute value of x plus 4 plus c. Okay. So rewriting that fraction that I didn't know how to do is what leads us to that. All right, then we get to some L'Hopital problems. If I were to put 0 in here, I'd get 1 minus 1, which is 0, over 0. And so L'Hopital says, well, go ahead and take the derivative. Derivative of e to the 3x is e to the 3x times the derivative of 3x, which is 3. Derivative of 5x is 5. Now try it again. So if I were to put 0 now, I'd get 3 times e to the 0. So 3 times 1 over 5, that'd be 3/5. Over here, if I put 0 in, I get negative 2 on the top. I get 7 on the bottom. That's my answer. So this is one, it's a little trick. They try to see if you do too much here. And really, it's just put it in, see what you get. On this one, if I let x get bigger and bigger and bigger, the top gets bigger and bigger, the bottom gets bigger and bigger. So we could do L'Hopital's, or we can say, well, wait a minute, if x is getting bigger, let's just look at the magnitude. What's the biggest term that we're dealing with? The biggest one on top is 3x cubed. The biggest one on the bottom is 4x cubed. Well, those x cubes are of the same magnitude, so one of these doesn't dominate the other. So this eventually, over time, is going to gravitate to the ratio there, 3/4. And that's our answer there. And then same idea on 15. Over time, as I let these get bigger and bigger, I see that this goes to the nth power on the top, and this one goes to the n minus 1. And so this is going to be a little bit less. Maybe this is 5 and this is 4. This is 12 and this is 11. So because the top is going to be bigger than the bottom one, the infinity on the top will be a much higher infinity than the one on the bottom. It'll dominate. This will go to infinity. Then we get our last one here. And what we're saying here is we want to integrate this just like we would normally integrate. It's just that we're going to say, instead of it, we're going to rewrite this and say, let's have the limit as b goes to infinity of the integral 5 to b. So we're basically doing a resubstitution here, saying, you know, instead of having infinity as a limit, which it really isn't, what happens as it goes to infinity? What happens as it gets bigger and bigger and bigger? And so we're going to go ahead and integrate this. This integrates actually into x plus 1 to the negative 3 over negative 3. And that's the limit as b goes to infinity on that. And if we want to rewrite this, this is, you know, a negative 1 over 3 x plus 1 to the third. You don't have to do that, but I think that would be a little bit easier to see what's about to happen. Okay. Now I'm going to go ahead and put the b in there. So we're going to get negative 1 over 3 times b plus 1 to the third minus negative, so plus 1/3 times x plus 1, or I'm sorry, 5 plus 1, which is 6 to the third. All right, take the limit as b goes to infinity. All right, so this is a lot of, you know, just we integrated doing power rule. We rewrote it, which you don't have to do. Then I did top minus bottom, okay? Now is the time you ask yourself, well, what would happen if I let this b go to infinity? What if this got bigger and bigger and bigger? And if this gets bigger, this is going to go to infinity. I'm going to get negative 1 over infinity, which will go to 0. okay, plus 1 over 3 times 6 to the third power, which is 216, and so times 3 is a 648, I believe. If I'm off on that, I'm sorry. But I believe this is then what happens. This integral converges to that value. So the area under this from 5 to infinity converges to 1/648.